Think about the world around you, the towering skyscrapers, the massive airports, the bridges you drive across every day, even the power grids that light up our lives. These huge public works projects are quite literally the backbone of our modern world. They are incredible feats of engineering, finance, and just sheer human coordination. But that begs a pretty huge question, right? How do these monumental, often multi-billion-dollar projects actually get built? I mean, who decides who gets to build them and for how much? Well, it all comes down to a highly structured and fiercely competitive process, one that's designed to turn our taxpayer money into the actual infrastructure we see and use every day. Okay, let's dive into how it all works. First up, let's look at the basic blueprint for any project. Before we even get to the cutthroat world of bidding, we need to understand the simple path every public works project follows, from an idea to a finished reality. At its core, every single major project follows the same fundamental path. It all starts with the contract. That's the all-important, legally binding agreement. Then comes the part we all see, the actual construction. And finally, you have completion, when the keys are handed over. But you know what? The most critical, high-stakes battle happens right at the very beginning, in that first step. And that brings us to the world of bidding. You can think of it as a massive competition. A government or some other public entity, they're the ordering party, lays out a project they want built, and then construction companies compete to win that job. The whole point is to find the perfect contractor, one who can deliver the best quality, under the right conditions, and this is the big one, at the right price. You know, this system has changed a lot over the years. It all started way back in 1951 with a really simple rule. The lowest bidder wins, period. But as you can probably guess, that led to some problems. You'd get projects that were cheap on paper, but ended up being poor quality. So by 1995, the system grew up. It evolved, recognizing that the cheapest option isn't always the best one. Now, it's a much more complex balancing act, weighing not just the price, but a contractor's qualifications, their track record, and their technical skills. And like pretty much everything else, this whole process went digital. The move to electronic bidding, or e-bidding, wasn't just about convenience. It had three huge goals. First, to make everything more transparent and cut down on the chances for shady, backroom deals. Second, to just make the whole process way more efficient. And third, to actually boost the country's overall economic competitiveness by making public projects run smoother. So, we know companies are competing on price. But how in the world is that price even determined in the first place? This is where we get into the real nitty-gritty of how these massive projects get their price tags. Seriously, think about it. If a government wants to build a new bridge, they can't just throw a number out there and hope for the best. Before any company can even submit a bid, the government needs its own benchmark. And they have a really complex system for figuring out a fair price, which starts with a couple of key terms you've got to know. First up is what's called the estimated price. This is basically the government's first-pass calculation of what the project should cost, without any taxes or fees included. It's a high-level ballpark number. Its main job is to figure out just how big this project is, and whether it's so massive that it needs to be opened up to international bidders. And that brings us to the base amount, and this is where the system gets really clever. The base amount is the key number that's used to create a target price. But here's the twist. Instead of just one single target, the system generates 15. That's right, 15 different potential prices, all clustered in a tight range around that base amount. And the bidders, they have no idea which of those 15 will be the final benchmark. That randomness is absolutely crucial. It makes it incredibly hard for companies to team up and rig their bids. All right, so the price range is set, the stage is ready. Now it's time for the competition. But you know, not all competitions are created equal. There are a few different ways for companies to throw their hats in the ring. The most common kind is a general competition. It's basically an open call. Any company that meets the basic requirements can give it a shot. But for really specialized projects, you might see a limited competition. This is where the field is narrowed down to only include companies with specific experience, a rock-solid track record, or some unique technical skills. I mean, you wouldn't ask a general home builder to construct a nuclear power plant, right? Same idea. Companies also have to decide how to present their price. With a lump sum bid, they give one single, all-inclusive number for the entire project. It's like saying, we'll build your bridge for X million dollars, period. But with a unit price bid, they break it all down. They price out each individual component, so much per ton of steel, so much per cubic meter of concrete, and so on. So, if we put this all together, the entire procedure looks something like this. First, the government decides on the right bidding method and announces the project to the world. Then companies get busy preparing and submitting their bids. After a winner is chosen, the contract is signed, and only then can the real work finally begin, which eventually leads to them getting paid. It's a very deliberate, step-by-step process. But hey, as we all know, no plan ever survives first contact with reality, right? Once that contract is signed and the construction crews are on site, things can, and often do, go sideways. I mean, this is the real world of construction we're talking about. What happens when unforeseen problems pop up? Is that contract totally set in stone, or is there some wiggle room to adapt? Well, the system has a formal process for exactly this situation. It's called a design change. This is the official way to alter the contract while the project is already underway. It can be triggered by all sorts of things, from discovering the ground on the construction site isn't what they thought it would be, to the government deciding to add a whole new feature to the project. It basically allows the contract to be a living document that can change to reflect what's actually happening on the ground. But, and this is a big but, there are very strict rules about when you can actually adjust the price. For example, if the original blueprints have mistakes, or if the actual site conditions are totally different from what was described, then yes, an adjustment is possible. But if a contractor just messed up their math on the original bid, where they overestimated their own costs, nope, that's on them, no price change allowed. Let's look at a quick case study to see how this works in real life. Here's a puzzle. What if the drawings for the project and the technical specifications match up perfectly, but they both contradict the official list of materials? Well, the rules are clear. In a conflict like this, the documents have to be corrected to match each other, and that process officially triggers a design change, which means a price adjustment is on the table. The system even has a way to account for huge economic shifts, like massive inflation. But again, the rules are incredibly specific. To get a price change because of inflation, two conditions must be met. First, at least 90 days have to have passed since the contract was signed. And second, the price of materials or labor, according to an official index, has to have changed by 3% or more. It is a really high bar to clear. So when you look at all the incredible infrastructure that surrounds us, remember that there's this invisible system that brought it all into being. It's a complex, highly regulated world of bids, benchmarks, contracts, and adjustments. A whole system of rules designed not just to pour concrete and put up steel, but to try and ensure fairness, manage risk, and ultimately to build our world. And that leaves us with one final, really crucial question to think about. This whole intricate system is a balancing act. Does all this complexity guarantee that we, the public, get the best value for our money? Or does it sometimes create so much red tape that it stifles the very innovation and speed we need to build the future? That's the billion-dollar question, isn't it? Something to think about.